Hello and welcome to fourth lecture in fifth chapter of our comprehensive course on machine learning, data science, artificial intelligence. Now, we are at present doing a chapter on numpy advanced features, and today we want to do this topic, understanding vectorized operation and array broadcasting. Now, as such in previous chapter, we have already done this, but this is important thing, and I decided that even at the cost of repetition, let us include it again in this chapter. What are vectorized operations? So vectorized operations are often called element-wise operations. But for vectorized operation to occur, certain conditions are satisfied, must be satisfied. Now the question is, when those conditions are not satisfied, then how does NumPy handle vectorized operation? So at that time, this concept comes into picture. That at that time, array broadcasting this occurs. So let us discuss these first, vectorized operation, and then array broadcasting. These are powerful features of NumPy that allow for concise and efficient computations. So first, vectorization. Vectorization allows performance to be performed on entire arrays rather than individual elements. It is often called element-wise calculation over entire array. For example, if you add two arrays, then the first element of first array is added in the first element of second array. Second element of first array is added in the second element of second array. Third element of first array is added in the third element of second array. So element-wise or corresponding elements are added in one stroke only. There is no need of for loop. There is no need of anything like that. But for that, arrays must be of same shape. However, the question is, if arrays are not of same shape, then can NumPy not handle them? Then yes, it can handle them. But for that, it internally does something which is called broadcasting. So it is for doing arithmetic operations between arrays of different shapes. First, we take example of arrays of same shape. So for example, you can see this is a list of 5 members, and this is also a list of 5 members. Okay, and we want to do multiplication of this and element-wise multiplication. Okay, so first of all, list needs to be converted into NumPy array, and then those two arrays are directly multiplied this way. You don't need any for loop or anything. So let us see what is the result of this. It would be this multiplied by this, so that would be 10. Next element would be 40, 2 by 20, then 3 multiplied by that, so next element would be 90, 4 multiplied by 40, 160, and 5 multiplied by 50, so 250. So then you can see that those elements are obtained. Now the advantage here was that both the arrays whom you wanted to multiply, they were of same shape. Okay, so then this operator immediately multiplied corresponding elements without taking for loop or anything. Okay, so what is the advantage of doing that? One, performance improves greatly compared to using for loop, and second, the code is readable. Once the person has been taught about the vectorized nature of NumPy, thereafter he will never be confused by seeing this symbol and this two on either side. He understands that this means that this symbol will be applied between corresponding elements of x and y. So this same symbol will be applied between 1 and 10, then same symbol will be applied between 2 and 40, same symbol will be applied between 3 and 30, and so on. And whatever the results are obtained, they will be stored in a new array. So then that is the plus point of vectorization. Okay. Now you can do the same thing with a for loop also, like this. First you create a list, and same list I have created, which was used inside this array. Okay, and the other list was also this. So that two same lists I am creating. Okay, but this time I am asked that do the element-wise multiplication, this multiplied by this and this multiplied by this, without using NumPy arrays. So that means keep list as list only and do element-wise multiplication. If I directly try to do that, say li underscore a multiplied by li underscore b, then it will throw the error. You can see that can't multiply sequence by non-int type of list. So that throws error. Okay. So what I have to do? I have two choices. One choice is that I can convert it into NumPy array and then multiply just two arrays. Or second choice is this, that design a function this way using a for loop. But this is a very tedious approach because the result of two lists is also new list. So first you create that new list, empty list which will store the result. Then you start your for loop that for I in the range len of this. So len of this means it will be 5. So I in the range 5 means 0 to 4. So 0th element will be taken first, then first element will be taken third, second element third, and fourth element. So for I in range 5, that is 0 to 4 element one by one, list multiple, list mul, this empty list should be appended with ith element of first list and multiply by ith element of second list. So if I is equal to 0, then 0th element of first list multiplied by 0th element of second list. So 10, that will be appended. Then next iteration of for loop starts. Is written, I will take, okay, so next iteration of for loop will start. So I will become 1. So first element of list A here would be, and first element of list B, these. Those two will be multiplied and the result will be appended here. Then similarly, I would become 2 now, next iteration, so I keeps on increasing. That is the nature of for loop. So then this is the next element. Okay, so that would be 3 multiplied by 30. Then I again increase this, 4 multiplied by 40. I again increase this, but that is the last limit because my I varies from in range the length of list A or list B because both lists are of same size. So then that means it is in length 5. Length 5 means 0, 1, 2, 3, 4. So this is the fourth element of this, and fourth element of this, they are also multiplied, and then my for loop is exited because I have already reached. So if I is increment more, then I will become 5. But then I is not in range len li underscore a because len of li, length of this list is 4. So 5 is out of that. So therefore the loop is exited, and whatever that final list mul is there after all this appending has occurred over for loop, that will be written. Now if I check it, and then this is, remember, this much is just defining the function. So nothing, no output will be seen. But now I am calling that function, that list mul equals multiply list, lia and lib. So I am supplying the two arguments, these two, and I am finding the list mul. So you can see I am getting my list that is the product of corresponding elements of the given two lists. However, these have several issues. One issue is that for loop is by default, Python for loop is performance wise slower. Okay. Second thing is, often this is prone to error. For example, let us just do one thing. If someone, a programmer by mistake, just takes this return statement inside the for loop. Actually, what should happen? The for loop should execute for all the elements so that this array is appended by all these numbers one by one. And once that result array is created, thereafter it has to be written. But this is a very common error, particularly for new programmers, that they return somewhere here. So then what happens? Let us see. You get only one element, first element, because after first element is appended in the list, then you are returning. So the for loop never gets executed for second element, third element. In short, the method is error prone. However, this way you can get the correct result, but then it is slow. But if you convert both into numpy arrays, so array A equals numpy array lia and array B equals np.array lib, and then just multiply. Okay, even this function definition is not required. You can just write here itself that array A multiplied by array B. Then you can get the same result and quickly. Now here there is one point, however, which you must understand. When I say you can get the same result, if somebody has a careful eye, he might argue that result is not same because this is a list. While here I am getting a numpy array. Okay, and then if you want to know that, then you can even check this, that instead of list mul, just write type of list mul and execute. Then you can see that it is a list. And similarly here also you can write type of array mul. Then you can see that it is ND array. So result might appear same in the loop, but it is not same. That is what I am saying, that they are two totally different data types. So when you are handling numpy arrays and Python lists, this is something which you have to be very careful and always keep on checking the type periodically in your code, particularly when you are learning, because there are certain functions which require arrays only, and there are certain things which require list only. So now the question is then what to do, because I was actually tasked with this thing, that these two are my arrays and get lists and get a result list like this. Okay, so I did by for loop, but I said that one is error prone if this return statement is inside, and I also said that second thing is performance wise Python for loop are a bit slower. Now then I would prefer to do it this way, but then I am not getting the list. No worries, just you have to write list of array mul. Okay, and first what is the output of this array mul that you see? Okay, then it is almost similar as previous, but outside clearly it is written array. But suppose you want to use this for some further processing where the input function is such that it only takes list as an argument, then what you will do? Nothing, no worries, you just take list of array mul. So the great thing about numpy array is that it can very easily be converted into the list or even matrix just by casting this thing which I had done by writing a list in front. That is called casting the numpy array into a Python list. Okay, fine. That is one thing. One more thing is why this performance gain is obtained in case of numpy arrays. Then the result is this, that arrays are homogeneous structure, that we know. That means that they are only having same data type. You cannot take 110 next in single quote A, next in single quote my name say Tejas. That is not allowed. All are integers and all must be integers like that. And therefore NumPy always stores the members or elements in contiguous memory locations. And therefore whenever they are used for any calculation etc., then the memory locations are not far away, they are next to each other, and therefore the calculation becomes fast. Second thing is that operations in NumPy, they are not done by Python code, but they are done by precompiled C code under the hood. And C is always faster performance-wise than Python. Okay, so this is the reason. But internally, you should understand that even when you do this array mul equals this, then internally actually for loop only is executed. But then why performance gain? Because this is Python for loop. While here, when you do NumPy array multiplication, then internally for loop is executed, but it is C for loop. Okay. So I have written here clearly, loops are nonetheless executed, but they are executed in C. Okay, fine. Now the question is, here I took a very simple example that these also have 5 elements and these also have 5 elements. So I could easily convert them into NumPy array, and I could easily find multiplication or even addition or division or any mathematical operation. Element-wise mathematical operation is possible provided the number of elements are same. The question is, if number of elements are not same, then is this NumPy totally useless at that time? Then no. NumPy has this feature, array broadcasting, which enables us to use this element-wise operations even when the number of elements are not same or even dimensions are not same. So one may be 2 by 3 array, another may be 3 by 4 array. So still I can use element-wise operations. How? That we will see in the next lecture. So thank you and see you in the next lecture.